Thank you, thank you. Welcome to this session in which we will discuss Helidon. So first of all, I have to say that I'm very happy to be here because I've visited many countries all over the globe, but this is my first time in Greek. So I'm really happy to be here. So today we're going to discuss Helidon, but before I have some logistic. So my name is Delabassee. I work at Oracle in Belgium. So I'm living on the French-speaking side of Belgium. So despite my French accent, I'm not French. But I work remotely. So I'm part of a team in the US where we are focusing on Java in the cloud, so serverless and other projects. So this is me some time ago in a conference in Sweden, and someone in the audience tweeted that it's not a real conference unless you read Oracle Safe Harbor statement at least once. So please enjoy. And last but not least, I'm using a MacBook Pro with that new butterfly keyboard. Anybody is using that kind of MacBook Pro? Are you enjoying the keyboard? Yeah, wow. So, well, anyway, that design, the keyboard design is really broken. It has been fixed for the fourth time by Apple 2 weeks ago, and people are still complaining. I'm using one of the early butterfly keyboard. So clearly, if anything goes wrong during my demo today, it won't be because of me, it will be due to the keyboard, who is really broken. So, Helidon. So I will first give you an overview of Helidon, and then we'll have some demos to basically see some of the part of Helidon in action. And we might have some time towards the end for Q&A. So, Helidon. Anybody knows what Helidon is? Because I think it's a Greek word, right? Yeah, okay, that's the only, it's a bird. That's the only place where I don't have to make any jokes regarding Helidon. So, Helidon, a type of bird with a slender, streamlined body and long pointed wings, which allows great maneuverability and very efficient flights. So basically, a swallow in English. Now, what is Helidon.io? Well, simply put, Helidon.io is a set of Java libraries for developing microservices. Everything is open source, so it's on GitHub. It's an Apache v2 license. You can follow us on Twitter. We have a public Slack channel where we basically the team behind the project is answering technical questions. But if you just have to remember one URL from this presentation, pick the last one. Helidon.io. So that's basically the website where you have access to all those resources and also a very nicely written documentation. And also the website itself is very well nicely designed. So that's clearly something that we at my employer are not used to do. So I think that we have a very nice website, so please make sure to leverage that website. So this is the Java Microservices frameworks landscape on how we see it. And basically, well, we see three types of frameworks when it comes to writing microservicing using Java. Bottom to top, we have first micro frameworks. So very lightweight frameworks with a limited set of capabilities that allows you to easily write microservices. So in terms of capability, they will be more limited than the other ones, but they will give you all the bases that you need to write microservices. We can name, for example, Javelin, Spark, Micronauts, and a few others. Then moving up, we have the microprofile-based frameworks, such as OpenLiberty, Payara, and so on. So in terms of capability, those frameworks are leveraging the microprofile specification. So they provide more capability than the macro frameworks. But the nice thing about those frameworks is that basically they are leveraging the microprofile specification. So that means that if you know how to use Java EE, like Java EE APIs such as JAX-RS, JSON-P, JSON-B, and so on, well, it will be very easy for you to write microservicing using those frameworks. And then we have the full stack frameworks, which clearly in terms of capability provide a lot of capabilities. But most of the time, you will not make use of all the capabilities that are provided by those frameworks. So we can mention, for example, Spring Boot, Jakarta EE, those type of full-blown frameworks. And then we have a few frameworks like Drop Wizard that floats between full stack frameworks and microprofile-based frameworks. So the question is where Helidon fits within that landscape. Well, Helidon is quite unique in the sense that it offers two programming models. So we have Helidon SE, which is clearly a micro framework. And then based on that, we have Helidon MP, which is Oracle microprofile implementation. So Helidon SE, as I mentioned, it's a micro framework that provides a functional reactive style. It's very transparent. So there's no container, there's no dependency injection. There's basically what you write is what you get. So they are very, very easy to use. And well, the programming style has been basically inspired by what we have on the JavaScript side of the world. So if you look at how we program Node.js, well, you will find a lot of similarities when it comes to Helidon SE. And then we have Helidon MP, which leverage the microprofile different specification. So that means CDI, JAX-RS, JSON-P, and so on. Clearly, Helidon MP is a declarative style. So it will leverage annotations a lot. Typically, that's what you do when you are programming using the JAX-RS APIs, for example. So this is a model that will likely be adopted by developers that are familiar with all those APIs coming from that space. So basically, Helidon gives you choice. On one hand, we have Helidon SE, which is very lightweight, and basically that's where we innovate. And on the other hand, we have Helidon MP, where we basically leverage the standard specifications that are coming from the microprofile space. In terms of high-level architecture, Helidon SE is composed out of 3 core components. We have a reactive web server that is based on DT. We have a configuration component, and we have a security component. And obviously, all the components are integrated together. So if you need to configure the web server, that will be done through the config component. If you need to secure your endpoint, that will be done through the security component. So Helidon SE is very simple, very transparent, no hidden magic, no tricks. What you get at the end of the day is a simple Java SE application that you run on top of a barebone JVM. Based on that, we have Helidon MP. So what we have here is the 3 core API of microprofile, that is CDI, JAX-RS, JSON-P, but obviously we are supporting a larger set of the microprofile API. And then we have some optional extension. So basically those extensions allows you to easily integrate the microservices that you will write using Helidon MP with external services, such as a database, such as a Redis queue, and so on and so on. Again, that project is open source, and it's optional, so you don't necessarily need to use them, but you can also use the extension on top of any CDI microprofile implementation. So strictly speaking, they are not tied to Helidon, the project. So if we zoom a little bit, if we look at the first core component, that's the web server. Everything is really based on that web server. So it provides a reactive and an asynchronous and reactive programming model for writing endpoints. We'll see later on that it has its own way of, it has a very simple way of programming those endpoints. Nevertheless, if you prefer to use the JAX-RS style, that's something that you can do. So what we see when we have Helidon SC, we have Helidon MP, but some of the capabilities that are provided by Helidon MP can also be used within the SC programming model. So we're talking about Jersey. So Jersey can be used within Helidon SC, JSON-P, and so on and so on. It also offers support for open tracing, metrics, health checks. That's something that we will see in the demo. Technically, it's built on Netty, so we are using Netty basically as the core underlying platform for having a high-performance HTTP engine. And the project is constantly evolving. So Helidon is a pretty new project. We're not even 1 year old, but we are constantly working on it to improve it. So on the web server side, we're adding capabilities such as the ability to serve static web content. So you can use your Helidon SC application as a basic web server. That's not a full-blown server, but still you can do static web serving. We have just added initial support for HTTP2 and gRPC, even though gRPC is not really part of the web server, but I think that's something important to mention. So if we look at the programming model, this is how it looks like in Helidon SC. You see, it's very simple to understand. So first of all, we are creating a web server. Then we need to specify the endpoints, the route that are provided by the web server. So we are using this builder pattern to basically define all the routes. In this case, we just have one route. So this method any basically means that our endpoints will answer to any type of HTTP request. Then this is the path, and we pass it a handler that will take care of the response. And what does the handler does? It just takes the response object and it sends it some basic payload. That's it. We build the routing object, we pass that object to the web server, and we start the web server, and we are done. We have a basic endpoint. So you see, it's fairly easy, and it's very simple to understand how it works. We then have the Helidon SC config component, and there are three main concepts within that component. So the idea of the config component is that it will provide you in-memory tree of configuration nodes. Those nodes are coming from a config source. So a config source is basically the physical location where the configuration information is stored. Out of the box, Helidon supports multiple type of different source, such as a URL endpoint, a config source stored in etcd, a git config, config source using Java system properties, and so on and so on. So we have the config source, and Helidon support different type of format. So for example, if you have an URL endpoint with some that provides some configuration information, physically the information can be stored in HOCON, in a YAML file, in a JSON file, and so on. So Helidon provides multiple parsers that you can basically attach to a config source. So you have a config source, you have a parser, and at the end of the day, this will give you your in-memory config nodes that you can use. The config nodes, so once everything is in memory, that's immutable. So that will not change even though the underlying configuration is changed. Having said that, Helidon provides an optional pooling strategy that your application can use to get notified when some of the configuration has been updated. So your application can react on some of the underlying configuration change if you decide to do so. And last, we have the security component. So it provides authentication and authorization. It provides also outbound security. So, for example, the ability to propagate security-related content, the ability to secure outbound requests, and so on. Right now, it provides multiple providers. So GWT, basic, HTTP authentication, OAuth, and so on and so on. And we are constantly looking at which one we should provide. So we're supporting Google Authentication, OAuth, but if that's not enough, and if we are not providing that out of the box, you as a developer can also extend, basically write your own security provider for Helidon. So that was a very short overview of Helidon SE, and based on that, we have Helidon MP. In a nutshell, Microprofile is basically an effort that was started a few years ago when the Java EE specification, so that was around between Java EE 7 and Java EE 8. And well, the evolution of Java EE at that time wasn't that great. I mean, it was very slow. So some actors, such as Red Hat, IBM, Tommy Tribe, decided basically to work on a new effort to basically leverage some of the key capability of the Java EE platform and add new API that are necessary to write microservices. So we're talking, for example, about metrics, about health check, those kind of API that were not part of the basic Java EE platform. So that's basically what Microprofile is, and since then Oracle has joined the Microprofile initiatives. So Helidon is basically Oracle's Microprofile implementations. So that's the high-level architecture. As I already mentioned, we have Helidon SE, then on top of that we have Helidon MP, but we have some of the capabilities, some of the API that are provided by Helidon MP that are also available, if you want, in Helidon SE. So a good example, JSONP and JAX-RS through Jersey. So you can use those in the basic Helidon SE. Now, in terms of programming for Helidon MP, well, there's nothing new. So this is basically how basic REST endpoints looks like in Helidon MP. There's nothing new. Why? Because this is simply JAX-RS, so the API that we have been using for years for writing REST endpoints. So we have a resource method. We're using two annotations in this case, get, so that means that this method will answer to any get HTTP request. And this is its path on the network. So /hello is basically where the location of our endpoint. So this is a very busy slide, and basically it shows what we, as of today, we are supporting in terms of API in Helidon. So in terms of microprofile, we are fully supporting the microprofile 1.2 specification. Having said that, we are working towards supporting microprofile 2.2, which was released some time ago. So that's something that we don't do fully yet because there are still missing parts. But we are already supporting some of the microprofile 2.2 APIs, such as, for example, I think that the config 1.3 is part of the microprofile 2.2 API. Not only that, we're also adding some extra API that we think are needed as the basis to write microservices using the microprofile specification, such as GPA for the persistence and GTA. So those two API are not, as of now, we'll see if they come, they are not part of the microprofile specification, but they are part of Jakarta EE. Nevertheless, we think that those are important. So we're supporting them on our microprofile implementation. And to be complete, this is basically the API that Helidon SE support as of today. So you see that, for example, JSON P112 is supported on both sides. And this is constantly evolving. This was for the latest release of Helidon, which was released, I think, 2 weeks ago, and next week we should have another release. And then we have those extensions that are based on CDI. So basically, those extensions are a CDI portable extension that you can use with Helidon MP. It's NP only because they are based on CDI, but you can also use them on other CDI implementation. So how it looks like, so this is, for example, the data source extension. So first, you need to configure your data source. In this case, we're configuring using the microprofile config approach. And once you have done that, you can inject directly this other object. So basically, you have a data source that you can use to connect to your database. So this is clearly a joke that only works in Tokyo. Its demo is it's a shop, a well-known shop in Shibuya. So it's demo time. So what we're going to see here, well, I will show you how we can bootstrap a Helidon application. We'll discuss about routing, how it works. Configuration, if we have time, we'll look at JSON support, and then we'll also try to look a little bit at the cloud support. So basically how you can turn your microservices into a Docker containers, and now you can improve things on that front. So, okay, so the first thing that I'm going to do, I'm going to create a basic Hello World Helidon SE application. So for that, I'm going to use a Maven archetype. So we are providing two archetypes that you can use to bootstrap a Helidon SE application or a Helidon MP application. And it always takes time when I'm doing that on stage. Pretty sure it's the keyboard. And whenever I say that it takes a long time, it really takes a long time. And I still have a network. So let's see. Okay, so Voxxed and the artifact, let's call it demo, snapshot, yes, okay. So we have a bunch of files which have been created, so let's have a look at what we have. but maybe first let's try to run that basic application. So it's a Maven project, so Maven package. It's basically a simple hello world application with a few REST endpoints. So something that you can see here is that when we build the application is being tested. So Netty, well, the application itself is being started. Under the hood, it uses Netty. And you see that basically, it took more time to generate the artifact than to build and test the application. So now we can run this application. So target, and we should have demo.jar. So this is the endpoints. So curl local host 8080 greet hello Voxxed. I can also update the greeting. So here I'm using a put basically with some JSON payload to basically update the greeting. So if I do it again, Salut Voxxed instead of Hello Voxxed. So it's pretty basic. There's really nothing important there. So let's have a look at the code of that. And I'm going to zoom a little bit so that you can see what's going on. So demo, demo source main Java. So we have two classes, greeting services and a main classes. So let's have a look at the main classes, because that's where everything happens. So basically, our application starts here, and we have this start server method. So if we look at that start server method, what does it do? Well, first of all, it configures the log, so not a big deal, and then it creates this config object. So this is the configuration component of Helidon in action. There's nothing specified, so we need to look at the API, what is being done there, and basically, by default, convention over configuration, Helidon SE will pick up the application.yaml file that is on the class path. So if we look at the class path, we should hopefully have, and we have one, we have an application.yaml that contains some configuration information. So it's a YAML file, and basically we have some configuration for the app and some configuration for the server. So next, we are creating this server configuration object using that config. So get basically mean, config.get basically mean get me this server, so this. So that's the port and the address, the IP on which we will bind our server to. So we're creating the server configuration object, and then what we do, we're creating a web server using that server configuration object. Not only that, we also have this create routing method, which is basically the method that we will use to create all the routing for our endpoints, for our microservices. So basically defining all the endpoints. If we look at that method, let's get rid of that for now. And basically, this is how it works. So we need to specify some route for our endpoint. So what we can do, we can, for example, say that I want my endpoints to answer to the HTTP GET method or to any HTTP methods. And then we need to pass it a payload. So I can do that like this. So my handler is getting two objects, server request and server response. So what I can do, if I just want to send some payload back, server response, and then the send method, and let's say hello Voxxed. So this is the most basic form of doing things. I don't specify any path. So basically, anytime I'm doing an HTTP, anytime I'm doing an HTTP request regarding of the method that is used, so get, put, delete, trace, and so on, my endpoint will answer hello Voxxed. So we can give it a try. And it doesn't work because, we need to fix the test. So let's fix the test very quickly. What? That's a joke, but you get the idea. That's only something that you can do when you're on stage in front of a large audience. But don't do that at home. But you'll see, it will work. No. Oh, did I save? Yes. I'm not sure my POM was imported. What? Skips. Oh, that was a test to see if you were following. And skip test, yes. That's the keyboard. Okay. So let's see, what did we do? So basically we define a simple handler that should always answer hello Voxxed. So let's give it a try. So curl localhost 8080 hello Voxxed. And obviously I can change the path and it will just answer hello Voxxed all the time. So the idea, this is basically how you can define your endpoints. So you can also obviously do more refinement, such as you only want to answer whenever we hit test. You can combine multiple handlers together. So for example, you can say the following. So here you want to answer whenever we have a GET request. So basically, let's just copy that one. So whenever we have honey on /test, we answer that. And whenever we have, let's say, GET on root, we will answer root. Obviously, that will not, well, what we need to do, no, that should work. We need to watch out at the order that we're using for our path. We also have the ability to use regular expression and get parameters out of the request that we have. So now if we try again, it's root, and if we, I think it was test, yes, hello Voxxed. So this is basically how it works. Now, so first of all, this is very simple. But the thing is that obviously, if you have more complex endpoint, it will be kind of difficult to work like that. So you can also use services for your endpoint. So basically, services works like this. So you you simply register a services. That you need to create. New my services. Oops. And it's basically an implementation of the services class provided by Helidon. And it has one method, update rules. And basically what we will do here is exactly the same. So we're going to use the rule object and basically, for example, we're going to answer get and on all the paths. So on the root, and whenever we have a GET request on that path with a typo here, we're gonna use the server response, send from handler. So that's okay, so that's the root path. So if we now try that, and I need to launch my endpoints. So now we have the payload that is coming from the handler. And the thing is that you can chain together multiple handlers. So what we can do, if we go back here, for example, let's see my service, no, here. What we can do, so my services, yes, this one. Oops, services here. So we can either decide to send a response, so that's basically the end of the change, or we can invoke another handler. So for that, we just need to use the request object, and then we invoke a next. And basically the next handler will be invoked, and so on and so on. So what I can do in my handler, I can do, for example, I can use the request, the request object to do some filtering, some checks, or some transformation, or enhance the request. And I will do a chain, and basically the last in the chain will have to do a send, to send a response to the client, or throw an error because something was wrong. So if we go back here, that's basically, let's have a look at what we had before. So this is how it works, basically, in a nutshell. So if we look here, we are registering JSON support. So this gives the ability to our REST endpoint to work with JSON payload. Then what we do next, we are registering a health object. If we look at the health object, this is basically a health support. So we have the ability to define multiple checks. Typically, we will create our own checks, or we can use the ones that are provided out of the box by Helidon. And that's what we do here. We're using the default health check. If we're looking at that object, what it does, well, it's simple. If it runs, so if the application runs within GraalVM, it will provide a heap memory check. If not, that's what we are doing here, it will provide a deadlock check, a disk space check, and a heap memory check. So we are registering the health check, so the default one, and then we are also registering a metrics object that will provide some metrics that we can use to see our application behaved. And finally, what we do here, we are registering the grid services. So like I just defined with my services, this is a services that will provide the multiple endpoints, like the ability to send the greetings or the ability to update the greetings, those kind of things. So we build that root object that will contain all the routes and all the services that we have attached to that route. And then we're passing that object to the web server when we want to start it. So that's what we are doing here. So web server create, and once we have created the web server object, we just need to start it. And once it's started, we will just print out some information. And obviously, something might go wrong because, for example, the address might be already bind. So we are just using the exception method to basically deal with any error that might happen. So if we look at that services, so I'm not, no, I didn't compile it, so Maven package. So we still have the local host 8080 grit Voxxed, hello Voxxed, but we also have two additional endpoints. I think it's health. It's not health. Sorry? Yep. It's okay. Thank you. And that was on the keyboard this time. But you see, so you see here, if I do that, it doesn't work. Why? Because this is not a space. This is just something else. And if I do that, this is now a space, and it works. So I wasn't lying about the keyboard. And we see that, so this is the default health check that are provided by Helidon. So we have the deadlock, we have the disk space, and finally we have the heap memory checks, health check, that are provided out of the box. And obviously we have the ability to define our own health check. So that's for health check. Now, we also have a metrics endpoint that is provided. I think it's metrics. And so those are some of the metrics that are provided. And so there is a base metrics that correspond to the microprofile metrics that are provided, that are defined within the microprofile specification. And we also have an Helidon specific metrics, set of metrics, that's the vendor metrics. So this format is for Prometheus, but we can also, I mean, if the client do the request and wants to get that in JSON, it will be sent in JSON instead of that format. But by default, this is the format that is supported if you don't specify anything. So that's basically how it works. So you see that it's fairly easy to start very quickly a REST endpoint, add its multiple, start a microservices, add it multiple endpoint, had metrics, had health checks, and so on and so on. So the next thing that we might want to do is basically to run that within a Docker container. So if you look here, we have 2 Docker files that have been generated when you create the artifact. So that basically means that we can -t Helidon sc and the build context. We can build our Docker container of our microservices easily. We are using Docker obviously to compile the microservices, so that means that we need to fetch again all the dependency. And we have we have multiple approaches to build containers. So you can do that using the Docker file that is provided. You can also use Jib. So Jib is basically a tool that is provided by Google that allows us to use distroless distribution. So that will reduce the size of your container that include your microservices. Or we can also use GraalVM to build a native image of the REST microservices. And so while it does that, let's quickly talk about that. So GraalVM is an open source, high performance polyglot virtual machine developed by Oracle Labs. It provides many capabilities, like the ability to run different language, JavaScript, Python, Ruby, Java, and so on and so on. But there is one capability that is very important when it comes to running a Java application in the cloud, and that is the native image capability. So the native image capability basically takes a Java application, so bytecode, and turn that application into a native executable for a given target. So let's say Linux, for example. And this is something which is important because the native executable will be smaller in terms of size. The memory footprint of that native executable will also be smaller. And also, that native executable doesn't need to have an underlying Java virtual machine or GRE to basically run. Why? Because GraalVM, so the native image capability of Graal, basically turn that Java bytecode into a native executable. That also includes a virtual machine, because we are starting from a Java bytecode, so that means that, for example, our code expects to have the memory management provided by some kind of virtual machine. So Graal basically embeds substrate VM within that Linux executable, so that we don't need any external GRE to run the code. So that will reduce the footprint, that will increase the startup time, and that will also reduce the size of the final Docker image, because we don't need to have a Java runtime, and basically we can also run on top of a Scratch image. So we don't need to have any operating system within the Docker container of our microservices. So let's see how it goes. It's done. So let's have a look at that. So Docker run P8080. Docker run. Oops, sorry. So our endpoint now is run within Docker. So that means that curl localhost, it's now 8080 and great. Message hello world. If I look at Docker, we see that indeed it runs within Docker. So let's kill it. Docker kill. So it's being killed, and obviously it doesn't transfer anymore. So we can have a quick look at that Docker image. Dive. What was the image? Helidon SC latest. So you see, I'm using Dive to see what's going on, and you see that it takes a bit of time for Dive to open the image. Why? Because the image is relatively large. So we can see here all the layers. So 55, that's the operating system layer. 147, that's the Java runtime. And then we have this, which is basically the Helidon application, so 5.9 megabyte. So at the end of the day, this is a pretty large Docker image for a simple microservices. So that's where Graal comes into play. So we have multiple ways of converting our image, our microservices into a Graal image. We can do that locally, or we can do that within Docker itself. So if we look here, we have a Docker. So Helidon native. And then we just need to specify the Docker file native and the build context. And that will build within Docker. I'm not, well, I will not wait till the end, because that takes that takes quite some time. It takes like 3 or 4 minutes, because compiling a Java executable, sorry, a Java bytecode into a native executable is a relatively expensive operation. But I've done that just before, and I have, let's see, grep Helidon. So again, you see, this is not a space, this is something else. So you see here, so 2 hours ago, so this is the one that we've just built. Well, over 200 megabyte. And just before the session, so 2 hours ago, I've built one using Graal. So basically more or less the same web services, 23 megabyte. And if we look in that image, so Helidon native latest, you see it's almost instantaneous. So you see the layers, numbers of layers. We have a scratch base image, so there's nothing. And then we have this 33 megabyte native Linux executable. That is basically the microservices with all its endpoints and substrate VM embedded directly. So that's really when, well, that's really one of the benefits that Graal provide. We have a super lightweight image, and the startup time, given that the images are very small, is also increased. Not only that, the memory footprint is also reduced. Now, obviously, we have to compare what is comparable. For example, the GC that we have here is more basic than the one that we have on top of Hotspot. So for long-running application, long-running microservices, then it's up to you to decide and measure which approach is better. So in terms of roadmaps, where are we with Helidon? Well, basically, we are just in Q2 2019, so we're working on microprofile 2.2 support. We're not there yet. We still have a few API to add. We have also already started to work on GPA and GTA support. HTTP multipart is supported. gRPC, we have an initial support already today. HTTP2 is already partly supported. And then we have a bunch of things that we would like to do, like having a reactive client, reactive storage, adding support for WebSocket, having a website to initialize a Helidon application, those kind of things. So we have a lot of things on our roadmap. So to summarize, Helidon.io, open source set of Java libraries for developing microservices. And the nice thing about Helidon is that you have the choice. You have the Helidon SC model, and you also have the Helidon MP model. So basically, on one hand, that's where we innovate on the SC side. And on the other hand, we are also making sure that we provide a standard way of developing microservices. That's where Helidon MP comes into play. So you have the choice. Helidon.io, that's the only resources that you need to remember. So give it a try. You will see that it's very easy to use. We have a lot of guides that will basically guide you through writing some sample application. And if you like it, please give it a star. Give us a star. It's a free. It's something that is free, and it's always appreciated when you work on an open source project and people are giving you stars. With that, I'd like to thank you. And I don't know if we have time for questions.
We do. We have time for 2 quick questions.
So are there any questions or remarks?
So what are the main benefits in using this over the hundreds of other micro profile frameworks?
Well, yeah. So why should we use this one over other microprofile implementation? We provide choice. I mean, we are providing a microprofile implementation. We're adding some API on top of, like GTA and GPA. And we have SC. So you might want to start with MP, and then at some point in time, you might want to look at Helidon SC. You still have the ability to reuse your JAX-RS endpoint that have been written using NP within SC. So it's basically about choice.
Great. One more short question, so we can move on. Anyone? Thank you very much, David.
Thanks a lot.